Welcome to Math 103. This is video number 1 on apportionment, the third chapter in the course. So what is this new topic of apportionment? What is the issue? Here's a warm-up. Pat and Sam work in the same office. Pat works 50 hours a week, Sam works only 25 hours per week. They work for the same office manager, and they are the only two people working for this manager. So they are, the two of them, just a small part of a larger company, let's say. At the end of the year, the manager has a certain number of concert tickets to give away as bonuses. If there are 3 concert tickets to give away, how many should Pat receive and how many should Sam receive? So think about that a moment. Pat works 50 hours a week, Sam works only 25 hours a week, and there are 3 concert tickets. So if you were Pat, how many tickets do you think you would be entitled to? And if you were Sam, how many tickets do you think you would be entitled to? There is a pretty strong case to be made that since Pat has worked twice as many hours per week as Sam, Pat is therefore entitled to twice as many tickets as Sam. And there are 3 tickets, so Pat would get 2 of them and Sam would get 1. That would seem to be one rational way of splitting them up. Another perspective is that the total number of hours worked per week is 75, and Pat accounts for 50 out of 75, in other words, 2/3 of all the hours, and therefore Pat is entitled to 2/3 of the total number of tickets, namely 2 of them. Sam, on the other hand, has put in 1/3 of the hours and is entitled to 1/3 of all the tickets. Or you can say Sam has put in half as many hours as Pat. Therefore, Sam is entitled to half as many tickets as Pat. And now we look at an example that illustrates why there is a problem of apportionment, why there is something difficult that needs to be solved. So we ask, what if there are only 2 concert tickets available? Same scenario, Pat has worked 50 hours a week, but Sam only 25. So what are we going to do? Are we going to give both tickets to Pat? That would mean giving none to Sam, and then Sam will think, well, why am I getting nothing at all? You know, I do work here, maybe not as much as Pat, but am I not going to get anything? Okay, so we don't want to leave Sam out completely, so how about if we give each person 1 ticket? Well, if Pat and Sam each get 1 ticket, now Pat is going to complain. Pat will think, wait, why am I getting the same bonus as Sam? I put in twice as many hours each week, and I have nothing to show for it. So either way, there's going to be someone complaining that they have been shortchanged. Well, you might say, okay, how about if they just sell the tickets? They'll just sell them for cash, and they'll split the cash. $2 for Pat for every $1 going to Sam. Right, so they can get their 2-to-1 split in money to reflect their 2-to-1 split in hours worked. Okay, there is something to be said for that, but then they risk getting a very low price when they sell the tickets, and then everybody's disappointed. So this is actually not as compelling an option as it might initially seem. So we're going to focus on the scenario in which we have to get rid of the tickets as such, and we need to decide who gets how many. To continue our warm-up for what the problem of apportionment really involves, let's look at another example of distributing bonuses at the end of the year. So at this time, the story is that a computer retailer has 25 iPad minis to give away as bonuses. It distributes them among the 6 members of its sales staff as bonuses at the end of the year. The retailer wants to distribute bonuses in proportion to how many computers each sales staff member has sold. We are given the data on how many computers each sales staff member has sold. So we know that Matt has sold 63, Vern has sold only 6. We ask, how many should each sales staff member receive so that we give away all 25? Using essentially the same logic as in the previous example of Pat and Sam, we can say that Matt sold more than 10 times the number of computers that Vern sold. 63 is over 10 times as great as 6, and therefore Matt is entitled to, he should receive 10 times or a little bit more than 10 times the number of iPad minis as Vern. And similarly, you can say that whatever fraction of the computer sales were done by Matt, that is the fraction of the bonus items he should receive. So the crucial first thing we could think about here is, what is the total number of computers sold? That turns out to be 139 when you add them all up. Right? And then we can say, well, Matt sold 63 out of 139 computers. That is a certain fraction of all the computers, and he should get the same fraction of 25 iPad minis. Okay, here's the problem. We can go ahead and compute the precise number of iPad minis that Matt is entitled to, based on his proportion of the sales accomplishments that year. We're going to do that computation in detail, and it's going to turn out, and it's almost always going to turn out, that the exact share that each person is entitled to of the 25 iPad minis is not a whole number. And that's a problem, because if Matt discovers that he's entitled to somewhere between 11 and 12 bonus items, what are we going to do? Are we going to give him 11 iPad minis plus some fraction of an iPad mini? Are we going to take one and cut it in half and give one piece to him and another piece to Connie? That's not going to help anyone, to start cutting iPad minis in half. That, or in smaller fractions. The problem of apportionment is precisely that these 25 items that we're trying to give away have to be given away whole. That's crucial. That's going to make this problem a little bit challenging. There are many other examples. Instead of iPad minis, we've already discussed concert tickets. There are going to be other examples of distributing items that are themselves indivisible. You're not going to take each individual item and cut it down any further, because it wouldn't make sense to do so. That is a hallmark of the apportionment problem. We are apportioning a specified number of identical items, each of which is indivisible. It cannot be broken into smaller pieces. Right? So the crucial example that we'll start in the next video comes from politics. The apportionment of congressional districts to states based on state population. So please continue to the next video.